We're about to show you the installation of a heat shrink joint to suit single core 33kV Xlpe cable. Using the instruction sheet, mark out the cable to the dimensions shown. Remove the outer cable sheath by using a sharp knife, scoring circumferentially, and using a suitable tool, cut down the length of the outer plastic covering. Wind back the filler tapes and remove with a sharp knife. As this cable is copper wire screened, we bend these back out of the way so we can carry on with the cable preparation. If the cable were copper taped screened, we'd leave the tapes on to the dimensions shown in the instructions. This now leaves us with the bonded semiconductive screen, which we'll remove to the dimensions shown in the instruction sheet. With a suitable tool, shave off the semiconductive layer down to this mark. If the semiconductive layer is easy strip peelable type, there's a different method for removing this, and we'll cover that in a different presentation. As you can see, the tool leaves a nice chamfered edge. You will now need to refer to the instruction sheet that will give you the dimension from the end of the semiconductive screen to the center point of the connector. Cut the cores to this point. It is important to be accurate here so that the insulation tubes overlap the end of the semiconductive screens by the appropriate amount. Remove the primary insulation to half the length of the connector used, plus about 5 mm. Before we proceed, position the nested insulation tubes over one or both of the cable ends. Not forgetting, of course, the outer heat shrink sealing tube. We're showing mechanical connectors here. Alternatively, compression type can be used. Tighten the bolts up in sequence until the heads shear. Before proceeding, degrease the connector and the primary insulation. And then apply the stress control tape with half width overlap and stretch, filling in the gap between primary insulation and connector. And across the length of the connector, as shown. The same tape is then applied over the semiconductive screen edge. The first tube that's fitted is the stress control tube. Position this centrally over the connector, overlapping the screen points equally at each side. With a suitable heat source, start shrinking from the center of the stress control tube to one end at a time. Keep the flame on the move all around the tube to ensure an even wall thickness. apply plenty of heat so the tube is completely wrinkle free. Now, as this is a 33 kV joint, additional layers of insulation are added. Center up the tube directly over the stress control tube, and once again start shrinking from the center to one end at a time. At 33 kV, 2 additional red tubes are fitted over the stress tube to give us the insulation required. At 17.5 and 24 kV, only 1 additional red insulation tube is fitted, whereas at 33 there are 2. We now position the combined insulation conductive tube. Center this up on the previously applied tubes, and once again, starting at the center, shrink in an even manner to one end at a time. Now at 12 kV voltage, this would be the only tube fitted. It's now time to apply the metallic screening. This is in the form of a copper knitted mesh, which is applied with 50% overlap across the joint gap and secured at each side. The copper wire screens can now be joined, and the method of doing this is by twisting them into a conductor . and then joining them with a crimp connector. To ensure a smooth profile, use more of the copper screening bandage to secure the copper wire screens to the joint. Mark out the position where the outer shrink tube will fit. And it's good practice to ensure a good adhesive key by roughening up the installation. Finally, position the outer tube to the points previously marked. And once again, starting off at the centre, shrink in an even manner to one side at a time. Once the tube is fully recovered, it should be wrinkle-free and sealant should be visible at the tube ends. The joint is now complete.